there will be 10 minutes, maybe 10, 15 minutes presentation. Then we will get our hands dirty. We will create a serverless application and we will deploy to AWS environment. And also we will then see, we will test it. We will try to investigate and see. So let's start with the what is that? So the architecture is actually the serverless is one of the architecture. It's quite popular nowadays, and according to Wikipedia, as you see, the software architecture refers to fundamental structure of software system and the discipline of creating such structures and systems. So each structure comprises software elements, relation among them, and the properties of both elements, relations, and design, and also documentation. This is the end of all the application development cycle. So if you look at the evolutions of the architecture, as you know, this is starting with the monolithic application. Maybe 10 years, not still even there are lots of monolithic applications. I've been working in my previous contract, which was a monolithic application. It was based on the .NET, MVC, and the partial views, Razor views, all in one solution, all in one in repository. So basically, it's just including the layers like facade layer, we can say the front end layer, and the business logic, as well as the data access layer, aka DAL. So these layers also become very popular, like 3-tier, N-tier, 4-tier, 5-tier, right? They call them N-tier applications, but they all refer to the monolithic application. If you see something tier applications, generally they are monolithic application. Then it comes to microservices. So microservice structure is quite, it's actually predominantly the backend architecture. What is the architecture? The actual architecture is actually they're doing the separating the concern. Actually, this is the aim of the architecture. So, for instance, if you have a customer-related operations, and if you have the let's say I was working in an insurance company, so we had the customers, we had the insurances, we had other third parties. So, for instance, all the applications with the customers, we can separate them between others. So the microservice architecture is actually separating the functional separation, but it's also the creating the small piece of applications. They all working together, and this is quite a big area because when you split to multiple microservices, the issue is how do you manage them? How will they talk each other? How will you communicate? How will they communicate each other's? And that's all the issues still. There are lots of discussions, but there are really, really good best practices with microservice designs. So generally it refers to event-based, event-driven architectures. So the microservices between each microservice, they communicate with the events or messages, we can say. So this is one of the very popular architecture, but there are lots of architectures depending on the requirement, of course. So this is still very, very popular and using in many companies. So the next stage also, this is the functions. This is serverless. As you see, the numbers are starting 1, 3 to 6, increasing. Why? Because there is a reason. because these functions are referring to actually maybe each endpoint of the service can be a function. What does that mean? Which means we can have a get function, like get endpoint. So these get endpoints can go a function. But if we think about microservice, a microservice can have multiple, there's not any definitions. Also, if Lambda functions or a serverless function can have multiple endpoints, but generally design says small pieces of work, and this is smaller pieces of work. We will, next slides, we will see the benefits and the drawbacks. So for the benefits, let's start with the benefits. The first thing first is of course, the reduced operational development costs. If you search for any serverless solutions, you will see that. So what is that reduced operational development cost? It's actually it's like an outsourcing solution, because the operational cost, there is non-operational cost, which is you don't configure any server. There is of course a server which runs the function, but we don't manage it. We don't configure it. It's like we are outsourcing the operational cost. So we are now focusing at the development. So the development cost is, and also this comes to applications have built-in service integrations. So you can focus on your building application. This is the development cost part. So you can increase your development efficiency. Also, it split big jobs into smaller tasks. This also increases your team's productivity, massively using the modality comparison model. So this is one of the biggest benefit. So the other one is, of course, scaling cost. So scaling cost is, there are several benefits to this, but on the basic infrastructure side, the biggest benefit is that you only pay for the compute that you need. So for the AWS Lambda, as far as I remember, down to 100 millisecond boundary in the case of AWS Lambda. So depending on your traffic, scale and shape, this can be a huge economic win for you. So with the AWS Lambda, with the other company solutions, it's horizontal scaling. So actually, what is horizontal scaling? We will maybe, there should be a next slide. I can explain this later. So horizontal scaling actually, it refers to increasing the instances instead of increasing the resource usage, which means if you need more instance, it automatically it creates new instances so that you can have more instances which can run multiple functions at a time. And the other one is easier operational management. So this is serverless applications have built in, again, I think this is similar to the operational cost. So scaling benefits. First, by the way, FAS, this is function as a service. This is a term they use for the serverless functions because they all function. So you might see some BAAS. This is backend as a structure. This refers to similar, but FAS is one of the, it can be the BAS solution as well. So scaling benefits of functions beyond the infrastructure costs, and also the reduced packaging and development complexity. This is the very, very easy with the functions. And the last one is greener computing. Yeah. And I found when I was looking for the benefits of using functions, I found this very interesting statistic. This is quite huge amount of idle servers. This is extraordinarily inefficient and creates a huge environmental impact. So the typical servers and business, so they are not in use, most of them. Whether we use a self-hosted server, we are still manually making capacity decisions about our applications that will often last months or years. So typically we are cautious, and rightly so, about managing the capacity. And so we are over positioned, leading to inefficiencies just described. With a serverless approach, we no longer make such capacity decisions ourselves. We let the serverless vendor provision just enough compute capacity for our needs in real time. The vendor can make their own capacity decisions in the aggregate across their customers. So this difference should lead to far more efficient of use resources across the data centers. Therefore, the reduction in environmental impact compared with the traditional capacity management approaches. These are the main benefits of using functions, serverless. So let's go back to drawbacks. So the drawbacks, one of the drawbacks is no server state. Yes, they are stateless, which means when you create instances, more than one instance, and you can't share the in-memory data between the instances. Well, actually, this is quite good at the, there is a 12-factor apps decisions which define the best practices for the applications. So if you look at the 12-factor app, the sixth one is you shouldn't use the in-memory state. Instead of, you should use the database or third-party integrations to manage your state, to store your state. But if you have in-memory state, I mean, if you have already using the in-memory state, so this might be difficult to handle with the lambdas. The other one is the functions will time out. Yes, there is a timeout if they are not in use after 15 minutes. They time out, or which that means if you have a function, or if you have a, let's say if you have an application which can take longer than 15 minutes operation, this might not be good fit for the function. So you might need to split it, or you might need to refactor, redesign the current application. That's the restriction. Also, there are some limits. So it says, for instance, the limit of the 1,000 requests can run concurrently. Any request above this limit will be throttled and will need to wait for the other functions to finish running. There's a detail in the link. I can share the details later. So I looked at the limits, and there are quite few limits that might be difficult for your current application. So you need to consider these limitations. And the other one is testing. Yes, with the serverless functions, testing is quite challenging. even in the current application, testing is challenging. So writing tests for an existing application, it's very challenging again. If you haven't started with the test-driven development, writing the test cases on a running application, this is challenging again. But also in the functions, it's a bit so. So there's potential cold start. So cold start, what is cold start? So cold start is when we are running a server function, it will stay active, which is hot, they say. And so as long as it's running, of course, and then the containers stay alive, ready, and wait for the execution. So after a period of inactivity, your cloud provider, or let's say AWS, will drop the container and your function will become inactive. This is called cold. And the cold start is when you execute an inactive function, there's a delay. And this delay might be an issue if you need, low latency application. So actually, there are some solutions for this. What is this? You can create, you can use some libraries to call your functions iteratively or periodically, let's say. So for instance, every 5 minutes, there can be a function which can call your functions so that your function can be hot. There are some ways to do it, but that's the reason. That's it for the presentation. If you have any questions, I can take before the starting development.
Hi, Ozgur. Thanks for that. That's great. I guess my first question is, I also come from a monolithic background and also moved to microservices. But thinking about function as a service, are there types of applications that you think that you wouldn't move from microservices to function as a service for any specific reasons?
I couldn't get it. Could you say it again?
Do you think that there are any kind of applications that you would not move from microservices to function as a service?
Well, this is a difficult question because it depends on the architecture and it depends on the requirement. There are some that if for instance, if you have a infrastructure of microservices communicating each other, and if you want to move to AWS Lambda or let's say functions, of course there will be a cost of it because you need to refactor or you need to redesign your architecture to work with the AWS Lambda or any function, which can have a cost of it. But that's the requirement. If you need to think, if you need to do so, you should redesign. You might probably you will redesign your architecture to work with the AWS Lambdas.
By the way, I think Ozgur, additionally, I can say, what you are doing by using microservice, you can do everything with Lambda. But as you mentioned, Lambda is not free, and also it has some warm-up issue. For example, if you are doing one IoT application, if you are developing one IoT application, and this IoT application handles millions of data per hour, for example, Lambda will be so expensive for your application. Of course, you can do everything via Lambda. It's up to your budget, and also, Lambda is a platform. What you are doing on your local machine, it is capable to do everything on Lambda. What kind of things we are handling with Lambda? Lambda is working with the other AWS services so well, interacting so well. For example, if you want to manage your authentication and authorization mechanism between your API gateway and also at the backend service, you can manage your authentication and authorization mechanism by using Cognito via AWS Lambda. It means you can inject your AWS Lambda to your middle of the process, and you can directly manipulate your data from the database, from the Cognito, from the identity access management, from the other services as well. I think we can say such a things. We shouldn't think I have to use AWS Lambda. In the first place, in my idea, architecturally, do we need to use AWS Lambda or not? Is it cost effective or not? Warm up is issue for our process or not? After that, we can decide, I think.
Okay, so thanks. So essentially, no technical reasons why you wouldn't want to move to Lambda, but perhaps costs can become prohibitive. And I do get that. But the good thing is that it obviously integrates with everything AWS, so and the other ones as well.
Yeah, exactly. Any other question, guys? Otherwise, Ozgur will jump to hands-on things.
Hi there.
Hi.
I have a question. What everything is between AWS with Firebase?
Sorry, Ellen. Can you say again? Maybe Ozgur understood, but I couldn't hear you. Sorry.
What is the difference between Lambda and Firebase functions?
Firebase.
Yeah.
I don't know what the Firebase.
Yeah. To be honest, Ellen, maybe Ozgur, I can answer these things. Lambda is not a unique solution. Every cloud platform have their own solution. As a serverless technology, as a without installing anything, any program or JVM or any runtime environment. For example, Azure has different kind of Lambda clone. GCP has different kind of Lambda clone. Firebase has also a different kind of clone of similar tool as AWS. The important part of the AWS Lambda, if you use AWS as a cloud solution, you can use Firebase, but out of the box. That's why better to, if you need some serverless solution on AWS, better to go, as a Lambda solution. Of course, you can build all of your infrastructure on a Firebase, and also you can run your Firebase functions. But what will happen if your Lambda Firebase function requires some AWS data, for example, some data from the DynamoDB, you need to call from the Firebase to AWS DynamoDB. It means your data will go out of the network. It is not secure way. Because in Lambda, we can do everything in a private subnet as well. It will be high performance. It will have high performance plus high secure. Yeah, I can answer like that. I don't know, is it clear?
Well, I want to add some words. So as far as I know, Firebase is Google's platform. I don't have experience with the Firebase, but the Firebase is a different platform. But for the serverless or for the functions, there are many vendors. Google, there's a Google, Microsoft, IBM, even maybe Oracle. We have some serverless because the companies are investing in serverless. So these actually functions are vendor independent. You can create your function in Google Functions or Azure Functions or in IBM. I don't know what is the solution's name, but I know that there are some solutions with different vendors. So actually, it's a bit vendor independent solution because you focus on your code, and you can easily deploy to other servers environment. It is easier than actually microservice deployment. It's easier than very much easier than the other monolithic applications deployment. So because you will just take your code and maybe few infrastructure changes, then you can move into any vendors. So there is not a comparison between this one and Google or AWS. That's different. With the functions, I think there's not much difference because they all provide very, very similar services. There might be some differences, of course, like limitations, using quotas, but the serverless is an architecture. So you can use Google, you can use Azure or IBM or any other vendors. But in this event, we will focus on AWS Lambdas. So we are develop an application specifically in the AWS Lambda because we will create an API gateway. We will use DynamoDB, so that these are all in AWS environment. Yeah, that's it. Any other questions?
I think we don't have other question. Yeah, one guy asked, do we have AWS trainings? I think we will. Yes, we are doing AWS events and trainings. For example, we will run a workshop about the AWS Lambda because it is a really big world. This is the only test of how can we use AWS Lambda in a simple way, but in general, in a professional life, in an enterprise application, how can we use? We want to show in a workshop as well, half-day workshop. I will announce it on our meetup. I will let you know.
Yeah, well, we will definitely have a workshop because as Rasim said, it's quite a big subject and there are lots of things, even for the vendor specific configuration, there are lots of things. So in this event, actually, we will focus on high level, the architecture and the high level, how it works, how can we develop an REST API with Node.js. But the details and debugging, error handling, all the designing, there will be definitely in the workshop. Any other questions?
Okay, could you explain that? I thought you are going to do some hands-on here. That's the whole point I joined this class at the moment, actually. Are you saying you're not going to do any hands-on?
I will just deliver.
Okay.
Well, then let's start with the creating a application. So I'll close this one.
Do you have a Git repo for this?
I have a Git repo, however, I have not published yet. So, sorry guys. I will.
You will. Okay, that's.
I will share it later. Yeah, I will share the link. Definitely, you will have the repository. So let me show you this picture. This one quite good example to demonstrate the Lambda. As you see this page, so it's the each event triggering the function and returning the response. Let's hello world from Lambda. And if they are clickable, by the way, if I click this one, so I'm increasing the events. As you see, when I increase the events, it starts to, this is horizontal scaling, creating new instances. And when I left clicking, then reduces the instances. So this is actually how it works behind the scheme. And the cost is, yeah, if we increase first, there is a, I guess, starting with 1 million something, then starting the costing. So if you increase the amount of, say, 4 million, 5 million requests, then it's increasing, as you see. This is really a good demonstration to see how it works. All right, let's start with the creating an application. So
just a quick question, if possible, about the cost. So you're saying that the cost will be so many invocations. So how many times the instances were created? So the script was running. It's not based on CPUs or server or anything.
Price. Yeah, if you go to pricing in AWS Lambda, they explain better. But the pricing is based on the calculation time and the
duration.
Yeah.
Also duration. You're charged for the duration as well. So.
Yeah, as I said, the calculation, the function time, and also the event. But these might not be just a sample of. It might be more than, you know, $13, or I'm not sure. This is just a demonstration.
Yeah, I understand about that number is not real, but the idea is the script could be large. It's taking certain CPU and memory. Is there any limitation on that, or is just how long it ran? And
there is a limitation, of course. As I said, there's, for instance, there is a 15 minutes timeout. If your function is running more than 15 minutes, it will time out. That there can't be any. There might be some changes, but as a base level, the function can't run more than 15 minutes, because you will pay each second, right? You will pay for each seconds of your functions running cost.
Also, I'm a little bit used to environment where I can buy certain CPU and certain memory for my data and execution, and then it's a fixed price, and I can call one event or whatever number, and it's always going to be the same price. But I see here in the model that it's based on the events.
Yes, based on the events, and it's based on the how long your function is running.
Yeah, by the way, Ozgur, by the way, we have several options. Of course, AWS propose also dedicated server to your for your application as well. And if you, for example, rent for 2 years their servers, their fees and bills, calculation will be completely different. AWS has several options according to your business plan. They propose, they have also dedicated servers. They have, if you run, some AI or big data application, they have different options. They have also transaction-based costs, time-based cost. For the bidding section is completely different, and they have several options. And yeah, by the way, for the cloud solution, we have to be care about the billing, and really it is so important. As you see in here, it says $33. It looks so innocent, but all of your fees come together. They are producing really. If you don't optimize your cost, you have to pay huge amount of money. The billing is completely different topic, and there is no only one proposal for the cost for the AWS. Also, also other cloud providers they have same policy as well.
I see it here now with the link that
nice.
That
Can I add something?
Memory.
Yeah.
Sorry, Michael. Go on. Sorry.
I wanted to say, I see that it is also based on the memory. So it's going to give you the tariff per 100 millisecond based also on the memory that you're taking and all this. So it's a complicated model. I understand that. Thank you so much. I wasn't aware of it. Thank you. You answered my question, and the link is very good.
Yeah.
Yes, guys.
Thank you.
Yes, guys. Can I add something about this point? Yeah, if you see the bottom of screen, it says that 128 megabyte function with a second invocation duration. So if we need more CPU power, we need more memory for Lambda functions. So this demo is based on this capacity of function. So if we increase the memory amount, when we need more CPU power, and then if we increase the invocation count, it will cost more.
Yeah.
So the capacity of function based on the memory it uses. You can't select a CPU size for Lambda functions. You can't choose a CPU.
And this is why we say they say.
Yeah.
This is the
AWS says that.
Actually, there is a server running, but we can't manage it. We can't,
Yes, exactly.
That's why they call serverless. So guys, let's start with the coding. So I will code. So I am assuming you all have an AWS account. So I will log into my console. If you don't have, I will show you just create an account. This is under IAM. So here, this is IAM service. You need to create an account. Why you need? Because you will use this account to use the AWS CLI. There will be AWS CLI. So this is my user. You will see I've already created that user. I have an access key. This is old. Yes, it says I need to update, maybe delete, recreate something. So you need to add a user. I'm assuming that you have an account, of course. It will be a root account. So you need a user, and you need to assign your user to admin group, which is better to work on the creating the environments, touching all the services. So that you need a user with an access key and the secret key which you will use. So that's the requirement to start with the development. And also when you get your user credentials, you need to install, by the way, we will use the serverless. What is serverless? Serverless is a framework. I'll show you here. Serverless.com is it? That's the framework I will use. So I will share this link in the chat box as well. You can. So let's start. The first thing I will create a name folder. I will give a name. Let's create that. Serverless.
So, sorry, Ozgur. Is it possible just to increase the font?
Oh, sorry. How's that?
Yeah, much better. Thanks. Yeah.
Express. We will use Express.js. Also, you can check Express. What is Express? Express is the framework again. It's a library for the Node.js applications. It's a REST API framework, one of the most popular framework, REST API framework. So we will use Express here, and I will install later. Let's create first the application. So serverless Express, let's say Express.js. Okay, so let's into. So I will, before starting, maybe I need to install the serverless framework. You have to install from npm. So I'm assuming that you have installed the Node.js, and then you can run npm commands. So I will install the serverless with the npm install globally serverless. So this will install the serverless. And then I will create my first application with npm init. When you install serverless, you need to configure with your AWS account, as I told you before. Here, you will use your access key and the secret keys to configure your AWS CLI. So to do that, you need to install the AWS CLI. Let me show you the AWS CLI. I will not install again as I have already installed. So let me show you the link. This is the AWS CLI. I will use it to configure my AWS account and to run some commands, AWS service commands. So there are some options here, sorry. So Linux, macOS, or Windows. I installed with the macOS one. It's quite simple guide. You can just click and install some packages and run it for your, depending on your operating system. So I've already installed the AWS CLI. I will also share this in chat box. So to configure your serverless, you need to type in something like as we install the AWS. This is like the common that kind of things we need to use. So SLS means serverless. You can use serverless or SLS the shortcut. So config will put my credentials. So here I will put my public key, which is coming from the management console, and the secret key is again coming from the IAM management console. So once you enter your credentials here, then it will be done. I've already added my credentials. So I'm deleting this part. So I am ready to start. I've installed serverless. I created an AWS account. I will initialize the Node.js project. Started this one actually, npm init. What is doing? Creating a JSON package JSON. Just a fast track create. package.json. So I will install some packages. One is Express. The other one is Serverless HTTP. So I will install these packages. These are the package. Still, I haven't opened any IDE, just installing the packages. I will open. So the serverless HTTP package is a handy piece of middleware that handles the interface between our Node.js application and this specifies the API gateway. So we can now open the project. But we use WebStorm, so I will open. So let me show my screen here. I am using WebStorm, guys, here. WebStorm is quite powerful IDE. For me, it's better than Visual Studio Code, but it's, you know, even in production, many companies using they are using the Visual Studio Code. But I prefer I was using before, so I'm very familiar with. I love JetBrains tools. I am an old .NET developer, so I used ReSharper, their product before. So I love the JetBrains products. So as you see, there is nothing here. Actually, they're just package.json. Nothing else about this is all the configuration of our Node.js application. But we will have more. We will add some more. So let's start with the check my items. We can create index.js here, maybe. Yeah. Okay. So my index.js, I will use the I forgot to install AWS. Actually, I don't need that. So I will Express. This is the initial, actually, Express REST API. Oops, Express. App Express. Let's define a port for now. Let's say 3000 that we will use. And app.get. This is actually defining my endpoint. This is a get endpoint with the, let's say, root endpoint. That will be address. And the rest will be callback function, request and response in the function. And we will response.send. This is our hello world. Hello serverless. Actually, it's not serverless. Hello from Node. Okay, what we need the listen, the app. All right, let's listen. So we can say the port I've defined and my function. When I was listening, I will say let's console log. Sample app listening. Oh, but it should be the backtick. Sorry. Let's run our first application. So how will I run? I will say node, just index.js. Yeah, and this is the console log saying wrong name, doesn't matter. Let's test it. Yeah. Okay, this is the initial start with the Express. So Express is working. We will define other endpoints for the other operations also, but we need to first implement the serverless part. So how will we do it? We need to add YAML file. So we will create a service YAML. So I will create a file. So serverless framework using it used the serverless.yaml file. This is all the configuration about the serverless framework. So I have well, actually there is a documentation for the show you docs dot serverless. You can check this website to how to to learn the serverless YAML, how to write serverless YAML file. But for now, I will use my template. So I've already created an application. So first thing first is need to do your service name. Let's say serverless Express.js. I will have a table name with my custom. Actually, let's skip the table. Just say provider and a function. What is that? Sorry. So this is the old one. I will update that. 12. I'm using version 12. You can always check with the node in terminal node -v or -- So our template is not using this one. So EU last, because my location is EU last 2. Yeah, and the stages there, that's the basic definitions. Well, I can maybe use that instead of the old way of defining the HTTP. Let's create this way. Let's remove this. First thing needs to be said. This indentation is very, very important with the YAML files. It's very important, all the YAML files. So this should be here. And I have to. You can always check with the serverless command, serverless verbals. So let's stop this and strong. Let me check that was the name. Was the wrong command. Okay, that's the good way to see the plugins and packages to each one is installed. What is the definitions in the serverless? Looks okay. What is the next? Oops. So we have now serverless YAML file. Yeah, we can deploy it actually. That's the basic one. But before deploying this one, I might have some existing check. So what is happening when you run serverless deploy? Actually, let me explain that. It creates a function with the name, and it creates the stack also with this name, and it creates the API gateway, and create a function which is called app function, and with the staging name, then bind our handler to this function. So at the end of the deployment, we will have API gateway and endpoint definition, and we will have a function. So before deployment, let me check. Actually, that's a good example. If I have an existing, for instance, let's see, and sort together. So deployment is actually serverless deploy command. Looks like deployed, and there was some warnings, which is the naming changing. Because of the version, they are updating the API gateway naming. So to do that, you can add provider under provider section, create an API gateway name like this one. And this should be true. This is how it works. Let's redeploy. When you change, by the way, this is important, guys. The serverless YAML, as you see this here, created a CloudFormation templates. What does that mean? That means it creates a stack. And this stack is all the infrastructures, all the definitions in the AWS environment. And the serverless automatically creates and updates the stack, and also creates the serverless zip folder, zip file, and puts your functions in that zip. You can have multiple functions, but in a single solution. And it creates in a single zip file, then deploy to S3 bucket. Then your AWS Lambda take this file and create the functions. So this is the serverless, how it works on the behind. So when you change in here in serverless configuration, you have to deploy it. But if you are changing, for instance, in the index.js, any change from here, which is not affecting the infrastructure, just code change, so you can deploy just the function with this. So here our function name is with the parameter index. You can easily deploy the only function as well. You don't, so that it will be quickly deploy. So as I updated the serverless YAML file, I will deploy all the infrastructure.
So So quick question: when you deploy, when you developed first, do you have two different folders, like you consider two different environment kind of thing, where you can develop in one and then copy to the production?
Yeah, think about this as a repository. So you can define the staging and you can change the staging environment. This serverless YAML file can be different in the different repositories. So for instance, in the dev branch, you can have this YAML file, but in the production branch, you can have a different YAML files. So that you can separate your production and dev environment, because this will create an API gateway with the dev stage. But if you change the stage, it will create another stage API gateway, which can be production or let's say QA. Yeah, pre-prod something, depending on your stage.
Okay, thanks.
No worries. So it looks like they're not issue, because why? Well, serverless fails, stand cannot be updated. Okay. This is because I have the existing function with the same name, I guess. Let's try with a different name. This is serverless 2. And redeploy. We can fix that issue as well by deleting our existing stack. I will show you later. So let's see that. Does it work? If it tries to delete the existing stack, it might fail. Then we have to delete manually. There are lots of definitions here. This is very similar to AWS CloudFormation, but easier than that because they just made simple solutions, creating the HTTP. There are some options here, like enabling CORS for API gateway, like this one, CORS true. As I said, in the documentation, there are lots of definitions. Looks like okay. Let's see. By the way, you can see also from here as well as from the CloudFormation part. Because as I said, it's creating a CloudFormation stack when you run deployment. Yeah, this is the second one. So these are the old one, and delete failed. Sometimes it failed because I was working on updating the stack, manually changing some things, so that it should be failed. But this is still in progress. So you can also click and see the events, what it has done, what it created. So these are all the services they call logical ID. So these logical IDs can be can refer to AWS services. Anyway, so stack has completed. You can go back. So it says yes, we have endpoints with this one, and the anyone is just the this is the type. The normally we have REST APIs, HTTP functions, which is the get, post, put, delete, update. These are very popular. Also, any is popular. They're just not defined like all the functions coming to this one. So we can test with this endpoint directly by clicking, because this is the just get one, and it will get the result. Okay, it's failed. So if you see this message, let's see from here as well. So we should have an API gateway. Yes, this is our API gateway. And let me see my exact same. So this is the any. When you type any method, it puts everything. So I need just the address of my API address, which I can see from here, just to see make sure that is it same address. Yes, it's showing error. So to see the errors, we can go to Lambda and check that what is the issue. So here there is a monitoring, as you guys see. It's my API gateway connected to my Lambda function, and here's my function. Simple function. We can test from here, or we can see the monitoring logs here. So let's see the test from here, for instance. I don't need anybody in my message. Just say sample. There was an issue with my, actually, can't. When I click this, I'm having an error. This is not related to application, but this is about my account in AWS. So let's see the monitoring and see the logs. What is the message? Is there any error that we can see in details? So let's click the CloudWatch. CloudWatch is another service to see your logs. Actually, it's a logging service provided by AWS. Let's see, is there any messages that can be helpful for us? Otherwise, I will check the code. Okay, it says handler not found exception. As you guys see, index handler is undefined or not exported. Okay, because there is a definition here, index.handler. So should be here, but there is not handler function. Well, I need to, actually it is the index file. Let me check. Oh yeah, I didn't export handler here. So I have to add my serverless to handler, module.exports.handler. Serverless. And I don't need to listen here. To do that, I have to put the serverless. So, yes. Let's redeploy and see. As you guys see, this is very easy to deploy. Just a few updates, and I can update the function itself as well, but I just wanted to update here. Also redeploy everything. Updating the stack. looks like okay. We can click here. Yay! As you see this message, looks like yeah. So the important one of the most important part is this one. Actually, I have to define the handler, and I have to put my serverless into that handler. This is the biggest part, because in the serverless YAML, I'm defining this. This is my handler, I am saying, because the AWS Lambdas are working with handlers actually. Everything starting with handler, so that I am actually assigning here. And I'm saying that my serverless app is the handler. So it's starting from here, then running my code in that part. This is also a good example for your existing applications. If you have a REST API Express applications, you can easily wrap them into a serverless application. How can I do this? You know that just needs to install this serverless HTTP. And this part can be anything. Just put your application into serverless and export in your handler. Then in your serverless YAML, just bind to any address or specific addresses. It can be get, put, anything, so that you can easily change your existing application to function actually. It's also a good example of showing how it works. Yeah, and from here as well, there are lots of ways to see and to test your REST APIs. Generally, I work with Postman. I use Postman. It's very good application. You can easily test your endpoints with all the HTTP methods. So for instance, in this case, this is the get address. We can type in here as well and send the message. And this is normally testers, or I am using this Postman to test my applications, REST APIs. So as you see, there are lots of things here, collections I've created. Yeah, and also one more thing. In API gateway part, just to show you how you test your endpoints. So this is, as you see, it's quite easy to create, API gateway. So if I go here, so this is the integration request, method request, all definitions. You can click this test, and you can easily, I will use get method. I will click test, and as you see, response from, this is coming from my function, and all the records, you can see the logs. The more detailed logs is also in CloudWatch. You will see when you refresh, there will be new, yeah, as you see this message, it is working. So we are, I guess, at the end of our time. If you have any questions, I'm happy to answer.
Yeah, first of all, Ozgur, I created an event about AWS Lambda for the enterprise application development. If anyone interested in how we are using AWS Lambda in an enterprise application, you can register to that event. I shared on the chat the event.
Yes, this was very high level. This is not the production ready example. Of course, it can't be, because we have a limited time, and we need some more time to dive into the details, error debugging, testing in with logs, and and maybe using other services, connecting with the AWS, for instance, DynamoDB, for instance, other services like SQS, SNS. So we can maybe we can talk in the other event in the workshop, maybe more detail.
Yeah. So guys, so far, how did you find? Do you have any questions? What do you think? Do you have any suggestion? Yeah, it's your turn.
Thank you, Ozgur. If you provide a Git repo with the instructions, we can reproduce on our own account. That would be marvelous.
Sure, I will share.
Thank you, guys.
Yeah,
it was a good demo course for who wants to start AWS and serverless, and to see a hands-on practice. It is very useful for beginners and who wants to start cloud coding on cloud and AWS. Thank you for your time.
thank you. Thank you to Ezra.
Thank you.
Yeah, guys, if you don't have any questions, we are about to finish. Thank you, Ozgur, for your time. You know, you did really, you spent so much time for this event.
Feel free,
Yeah.
guys. If you have any questions, just you can reach me from LinkedIn. That it was in my, I guess here. Did I put? No, sorry. I will also put in the chat box just for you to connect each other.
Mm-hmm.
This is my. All right. Here is my link. If you have, as I said, any other questions, you can always reach me. Thank you, Rasim,
Yeah.
organizing
Thank
this,
you.
for hosting me, and see you in next challenges.
Yeah. We will work. We will continue to work with you, Ozgur. Thank you so much for your efforts, and you shared all of your experience. Guys, this experience was really important, because if you don't know how to use something or what, from where, it will be a nightmare if you have, deadline or something. That's why I think you understood a little bit how AWS Lambda works, why we need serverless architecture, do we need or not. Hopefully you understood a little bit. But you can improve yourself, or you can follow us, and you can follow our other events, because we are running so much tech events about different topics, trendy topics. Thank you for attention.
Thank you.
Going.
Let's
Yeah.
go. Have a nice evening. Take care, guys.
See you. Bye. Özgür sen kal. Okay. Adam gitmiyor kardeşim ya. Dur şuraya alan var ya.